Hello guys, let's talk about balancing chemical equations. Balancing chemical equation it means that you are trying to make an equation that the number of atoms in the reactants be the same as in the products. So a balanced chemical equation has an equal number of atoms of different elements of the reactants and the products on the both sides of the equation. A balanced equation gives us more information about a reaction than we get from a simple word equation. As we've already talked about the word equation, that it only talks about the words and how the reactants react just to give out the product. But a balanced chemical equation, there is a chemical equation that shows the reaction, how it takes places, so it gives us more information. Now below is the step-by-step approach to working out the balanced equation for the reaction. The first one, that write the chemical equation for the reaction with the correct symbols and the formula of the reactants and the products. Then the second procedure, that identify different atoms of the different elements of the reactants and the products. The third one is that check whether these different atoms are equal on both sides of the equation. Now some atoms may balance each other directly, while others you need to check out and balance them. That means that the amount of the number of atoms to the reactants, you try to look it, are they the same to the product, and give out the balancing. Now the other procedure that balance the atoms on each side of the equation by hit and trial method. This hit and trial method, it means that you specifically analyze the amount of atoms in each side, and if there is a number that is missing, in order to balance it, you add it to the either side, that is either it's reactant or product. And the other procedure is that add state symbols. Now this add state symbols, the last procedure where you have to add whether the reactants or the products are in which phase, solid, liquid, gas or aqueous. Moving on, let's see the ionic equations. Ionic equations are equations in which the reacting substances are represented in ionic forms after the elimination of spectator ions. In other words, you can say that ionic equations are those equations represented in such a way that the spectator ions are not included in the final equation. Now what are spectator ions? Spectator ions refers to those ions which do not change during the reaction. This means that they do not take part in a chemical reaction. There are no changes that they occur. So in order to be able to derive an ionic equation from a molecular equation, one must be acquainted with the solubility rules as outlined below. The first one is that all sodiums, potassium and ammonium salts are soluble. So this you should notice when you are trying to make this ionic equation. The second is that all nitrates, chlorates and acetates are also soluble. All binary compounds of halogens other than F with metals are soluble except those of silver, copper, lead and mercury. These halides are soluble in hot water. The other is that all sulfates are soluble except those of silver, lead, mercury, barium, strontium and calcium. All carbonates, sulfates and phosphates are insoluble except those of ammonium and the alkyl metal, that is group 1 cations. The all hydroxides are insoluble except those of ammonium, barium and the alkali metal, that is group 1 cations. All sulfates are insoluble except those of ammonium, alkyl metal cations and the alkyl earth metal, that is group 1 cations. Now all oxides also are insoluble except those of calcium, barium and alkyl metal. These insoluble ones actually react with the water to form hydroxides. So these are all that you should be acquainted as a matter of solubility rules, in order just when you're trying to analyze the ionic equation. Moving on, let's see the steps for writing balanced ionic equations. The first one that write a balanced formula equation for the reaction in order that it should be clearly written that the number of atoms in the reactants should be the same as the number of atoms in the product. Then split all soluble reactants and the products into individual ions, clearly indicating their state symbols. Remember that the substances that exist as molecules such as water, gases, and the concentrated mineral acids, precipitates, and the neutral atoms do not consist of ions and hence do not ionize in water. And the other step is that cancel out all the ions which appear on both sides of the equation, which are the spectator ions. So after removing these are ions which remain unchanged, as we said before, the ions which remain unchanged in the end of the reaction, and then you rewrite the remaining ions. Now this is the net ionic equation for that reaction. I hope the steps are clear. So thank you for listening, guys. I hope it's clear. To be more clear about these steps, I suggest that you pass to various examples of a balanced equation and how to write them as the ionic equations. Thank you.